This podcast is about a problem involving two sleds. So first I'm going to read the problem. A frictionless plane is 12.3 meters long and inclined at 34.2 degrees. A sled starts at the bottom with an initial speed of 5.15 meters per second up the incline. When it reaches the point at which it momentarily stops, so the velocity is zero, a second sled is released from the top of this incline with an initial speed of vi. Both sleds reach the bottom of the incline at the same moment. The acceleration of gravity is 9.8 meters per second squared. Find the distance that the first sled traveled up the incline. And then the second part of the problem asks, find the initial speed of the sled. So the first thing I'm going to do is draw a diagram of the situation. And there are really three parts of the situation. Here is the beginning. Here's the first sled. This is its initial velocity. This whole length of the board is 12.3 meters. At this point, the velocity of this block is 0, and the angle of inclination is given. Then, the middle block drifts up to here until it comes to a rest, and its velocity is 0. At that point, the velocity of this block is vi. Angle of inclination is still the same. Velocity of this block is the same. That's this block when it was down here. And then, at the end of the problem, both blocks are here. The purple block is under the green block. The initial velocity of the purple block was 5.6. Initial velocity of this one we don't know. And the purple block went up, came back down, and the purple block came down and landed on top of it. So we have 3 times. Time equals 0. So up here, middle time equals t1, and the end time equals t2. So the first thing I'm going to do is calculate the acceleration of each one of the sleds. In order to calculate the acceleration, I have pulled off just one of the blocks and put it in the center of the diagram, so it's easier to draw the free body diagram. Now, in the problem, it did say that this is a frictionless incline, so I'm going to draw my force of gravity. All situations always have a force of gravity. I started at the center of my object and went in the direction of the force, which is down for gravity, and it is resting on a surface, so I'm also going to have a support force or normal force going up. Let me go ahead and label those. Fn and Fg. Now looking at the coordinate system of the plane, if we are standing right here, with this located arm there, if we are standing right here, then this is our y direction. So Fn is only acting in the y direction, and this is at an angle. So we're going to have to do a triangle to figure out the components of this in the y direction and in the x direction. Let's look at our situation first. And remember, we're trying to find the acceleration of this block. Well, if we look at the y direction, there's no acceleration in the y direction. So sum of the forces in the y direction equals may, M-A-Y, but may is equal to 0 because it is not accelerating this way. So we could say that Fn minus Fgy is equal to 0. This is Fgy, the y side of the triangle, but we don't need to know that for this problem. So we instead want to focus with the force that's causing the acceleration, which is Fgx, this side of the triangle. Now, in order to find Fgx, we need to get an angle inside this triangle. Here's our big triangle right here. This is a right angle. So if this is 34.2, this must be the complement of 34.2, because a triangle has to be 180 degrees altogether. 90 here, plus the combination of these two has to be 90 to give 180. So if we extend our gravity triangle here, you can see that this line is perpendicular to here, and also this, by definition, the support force, or the normal force, is perpendicular to the surface, so this is a right angle. If this triangle right here, this little triangle, this is 34.2, this must be our complement. Also that with two hash lines, same as this. See, small triangle and big triangle are similar triangles. Then if this is a right angle, to get to a flat line, this whole thing must be 180 degrees. So here's 90. This is the complement of 34.2. So this is 34.2. This is a right angle because it's the x and y axis, so it's always perpendicular. Now we can find FGX. FGX is opposite to that side, so we're going to use sine 34.2 equals opposite FGX over hypotenuse FG. Now in this circumstance, FG, let's move it over here first and solve for FGX. FG is always equal to mass times gravity, because that's the definition of the force of gravity. Here's the mass of your object, here's G. You say, we don't know mass. Let's not be concerned. We just put mg sine 34.2 equals FGX. And let's see, is that going to the left or the right? That's going to the left, so it's going to be negative. Okay. Now, let's set up, we did our y equation, but we know that the acceleration is the x direction. So sum of the forces in the x direction is max. That equals only one force, FGX. And we know that FGX is going in the negative direction. We have to consider the sign of AX. AX is speeding up in the negative direction, so a negative times a positive. It's a negative, and we have a negative there, so that makes sense. So let me substitute that in. MAX equals negative mg sine 34.2, and I have an m on both sides. Cross that out, and I get AX equals sine 34.2. Oops, times G. There's a little G in there. And if I substitute in 9.8 for G, sure we follow through with our negative sign, and the I and the sign. 34.2. Plug that into the calculator, and we get negative 5.508 meters per second squared. Okay, it's the first step of our problem because we need to know the acceleration. Now the next thing we're going to do is find the time it took for the sled at the bottom to drift up to the point where it stopped, because we need the time in order to find the distance. We know the whole distance is 12.3, but we want to know how far the sled drifted before it came to a stop and came back down. So for the purple sled, we know that in this case, VF is equal to 0. VI is 5.6, because they gave that to us in the problem. A is negative 5.508, what we just calculated a moment ago. and we're looking for t. And the good news is that is our easiest motion equation. Vf equals Vi plus At. So we get, remember we know it's this equation because it has the 4 variables that we care about. Now when I move 5.6 over here, it's going to become negative. And then I'm going to divide, the negative sign will cancel out, and I get 0.935. Okay, now that I know the time, let's go ahead and use that, and let's find our distance. So this time I know Vi is still equal to 5.6. Vf, 0, time, 0.935 seconds, meters per second, because I just found that. Acceleration, still negative 5.508 meters per second squared. And now I have 4 variables, and I want the 5th. So I'm going to use the one that's already solved for d and do Vf 1/2 Vf plus Vi times t. And I get 0 plus 5.6 times 0.935. And simplifying that, I just do 5.6 divided by 2 times 9.35 in the calculator, and I get 2.407 meters. All right. Now, we haven't ended up using any information from the second sled, but there's still time because we're going to do part 2. So, in part 2, now it asks to find the initial velocity of the second sled. So we want this Vi value right here. So let's look back at what we have, and this is the end of that circumstance. So we already found the time for the sled to drift up the incline, and because the same acceleration is acting, that is also the same time it takes to go down the incline. So we can still use that time interval of 0.935 seconds. And we also know the acceleration for the whole circumstance because we found that earlier as well, negative 5.508 meters per second squared. We don't know Vi because that's what we're looking for. We don't know Vf, but we know that d, because we're going down the incline, is negative 12.3 meters. So I have A, T, D, and I want F. So that fits d equals VIT plus 1/2 AT squared. Another one of our motion equations. Acceleration is constant, so these equations are valid. So negative 12.3 equals Vi 0.935 plus 1/2 negative 5.508 0.935 squared. Squeeze that in at the last second there. All right, so let's simplify just a little bit here with our algebra. This is a number times a variable, and then this whole thing multiplied together, it's going to be negative, because here's the negative sign here. So 5.05 5.508 divided by 2 times 0.935 squared is 2.408. I'm going to add this over to this side because it's negative, so I'm going to add it to get it off the other side, and I end up with negative 9.892 equals 0.935 V1, and then I divide and I get negative because there's positive on this side, negative on this side, so it stays negative. 10.581 meters per second equals VI. Now, were we expecting a negative velocity at the end? And the answer is yes, because this one is going to the left, so it will definitely be in the negative direction.